So we're going to be focusing on joint E, and joint E, we know a lot about it already. So let's see, we have this up and down force from our picture, that would be BE, and then a force coming from EC, and we know that there's a 20-pound force as a load, so I'm going to say this is 20. The EC, that was, I think, 110.68, 110.68, 0.679, whatever. And BE, that wasn't that like 20 something, 27.5? 27.5. And then I also have this force over here. I need this one. This is F, the force between, what is that, DE, I think? FDE. DE. Now, how can I get that? Well, the first thing that I'm thinking is, well, I can sum up all the x direction forces, and they have to equal 0. So I can get the x component of this and add it to this, and then this x component here would have to counteract that. So that's my first task. I'm going to get the x component of 110.679. And how do I do that? Well, from my picture, this was EC. That was the force within EC. So let me just draw real quick the truss. We had this. EC was over here. No, that was BC. EC was this. So really, to find the x components of that, I need this angle. I need that angle. And to find that angle, I already know that this is, from the picture, this is 10, and this is 30 over here. So I can use, so that's 30, this is 10. This is just from my picture. So I'm trying to find that angle. I don't remember if I used, I'm going to call this angle phi. I accidentally wasn't recording when I was talking. Anyway, I'm going to call that angle phi, and then I know that I can find that by doing tangent, and that would be opposite over adjacent, so 10 over 30. And then inverse tangent will give me what phi is, and that's 18.435 degrees. So I have that angle. Remember, my overall goal was to find the x component of EC, so I'll use that. Now I have regular EC, which was 110.679. Its x component I can figure out just by using the phi, that angle. And now we I need this, so that's the adjacent and the hypotenuse. So I use cosine. Cosine of 18.435 degrees. That has to equal the force of EC in the x direction. ECX. So equals adjacent FECX over the hypotenuse 110.679. I'll multiply both sides by this to get my answer, EC in the x direction, and that I'm going to round up to 105. So I have that as 105, and I know because the x component here and the 20 here, that has to add up to be the same as FDE in the x direction. So what I'm going to do is I'll just take the 105 plus the 20, and that must equal FDEX. So FDE in the x direction is equal to 125 pounds, but I still need FDE, not just FDEX. So it's DE, that's this one. But I have just the x component. How can I find the whole entire thing? Well, I know I have a triangle. And from the picture, this was 10 feet. And the bottom here was 20 feet. So perhaps, I already know that this, well, let's just find this angle. Let's call this phi 2. Let's call it phi 2. So to find phi 2, this is 10, this is 20. Phi 2, That's just tangent. Tangent of phi 2 equals 10 over 20, or 1/2. Use inverse tangent, and I get 26.565 degrees. And now, well, I already know that FDEX is 125. And I want to figure out that hypotenuse, and I have this angle as around 26 something. So if I want to use SOHCAHTOA again, that would be adjacent over the hypotenuse. So I would do cosine of 26.565. That has to equal 125 over FDE. We're almost done. We're almost done. So I'll switch those two, and FDE will equal 139.754, and that we already decided that was going this way, so that means, this is joint E, right? That's joint E. So that's going like that, it's going like that. That means it's pushing, it's under compression. So this will be under compression. You can add this to your list, LB. Yeah, I don't have the rest of the list copied down, but there you go. That's the last force. We're done. Goodbye.